Okay, in my absence, I asked you to complete the last 2 pages of notes, so that's where we're going to carry on from. So let's start with practice 4. Estimate the value of 79.5 minus 3.21 times 29.25 by rounding off each number, correct, to one significant figure. Each number. They did not say to find the final answer, then round it off to one significant figure. They said round off each number. So what are the numbers? We've got your 79.5, 3.21, 29.52. Every single one of these, round it off to 1 SF. Okay, so our presentation will look as such. So 79.5 minus 3.21 times 29.52. We round it off. Every single number, remember we wanted, since we want 1 SF, right? We draw a line over here. Draw a line after your 1 SF and look at the decider. Now in this case, the decider, it is 9. It is a big number. So we expect the 7 to increase to become 8. So this is approximately 8 minus 3 times, sorry, this is 80. 80 minus 3 times 30. So our BODMAS tells us that we have to do the multiplication first. We end up with 80 minus 90. And we get negative 10. Right? Any issues? So this is a recap on our rounding off to significant figures. Any questions before I move on? Otherwise we can go on faster already. Okay, so estimation can allow us to quickly check our computation. But we must make sure that our estimation is, to a certain extent, accurate. And it must be reasonable. So let's take a look at example number 5. What happens? We have a plot of land. It's got 56.482 meters long. So this is an example of a number that is very precise. Very precise, a lot of significant figures. And it is 13.871 meters wide. Okay? Without the use of the calculator, estimate. So in part A, area. Since they want us to find area, you write down area equals to, our formula states, length times breadth, 482 times 13.871. And now, do the estimation. What would you like to change your 56.428 to become? Something that is reasonably easy for you to, estimate. So because they said giving estimate the area of this land to the nearest integer. Okay, so integer over here. Remember we talked about the definition of integers. We've got positive, negative whole numbers including 0. So let's change all these numbers to whole numbers first, the nearest ones. So 56 multiplied by 14. So without using calculator, right, you can do your 56 times 14. Okay, so after you've done that, you end up with 784 square meters. So that's the answer for part A. And then in part B, it says calculate the area, giving your answer correct to 3SF. This time, we take 56.482, 13.871. Let's see what our calculator gives us. (783.46 square meters). And it says, correct to 3SF. So draw your line with a pencil. This is our the first SF is the 7, followed by the 8, followed by the 3. So this is where we can draw the line, after the 3. Okay, so our decider is 4. 4 is a small number. So we don't need to change the 783. And therefore, our answer to 3SF is as such. And then we have a part D. Part D says compare. Oh no, round off, okay, 56.482 to 3SF, so we get 56.5. The other number is 13.871 to 3SF, 13.9. Calculate the product of the values in D part 1. Okay, let's multiply them together. 56.5 times 13.9, we get 785.35. Then they say give your answer correct to 3SF. Okay, now 3SF, 785. In E, it says to compare the results in B. Okay, so the results in B, our 783 versus D part 2, 785. Are they the same? Alright. Are we actually calculating are we trying to calculate the same thing? In part B, we are calculating area, right? In part D, part 2, what are we calculating over here? What is this 56.5 times 13.9? What is this supposed to give us? Is it also a calculation for area? When you take 56.5 times 13.9, are we also calculating area? What do you think? Is it? Yes, right? We are calculating area also. Hey, but why are the two areas different? Something wrong? I mean, it can't be the area is 783 and 785 at the same time, isn't it? Something has to be wrong. Which value do you think is more accurate? Part B versus part D, part 2. Which one is more accurate? B? Okay, who thinks it is B is more accurate? Raise your hand. B? Who thinks part D, part 2 is more accurate? D, part 2? Okay, we have slightly more who choose part B. Let's go back to part D. What are we calculating in part D? Area, 3SF. These are the original numbers. 56.482, 13.871. In our calculation in part B, did I use the exact values? Did I use the exact values? Yes, I did. I used 56.842 and 13.871. I multiplied them together and I had this value, right? 783.46. This 783.46 is the exact. This is the exact answer. It is the most accurate answer over here. Subsequently, we rounded off to 3SF. Because the question asked me to round off to 3SF. So 783.46, which is correct, rounded off to become 783. We compare that with what we did in part D. In part D, we rounded off the exact values, 56.482 to become 56.5. When I round off at this part, we lose accuracy already, right? This 56.5 not accurate anymore already. When I take 13.871, I round off to 3SF, again not accurate. You take two numbers that are not accurate, you multiply them together, do you think your answer will be accurate? Logically. You take two answers that are not accurate, you multiply them together, will your answer be accurate? No. So we need to get this logic. When you start rounding off at the start, and then you use the rounded off answer, you have to acknowledge that your final answer is not going to be accurate anymore. And that is why we ended up with 785, which is very far away, very far off the exact answer. What was the exact answer again? It is the one in green, 783.46. This 785, too far away already, it's not accurate. A better estimation is 783. And how did we get that? We found the exact answer, then we round off. That is the way we should do it. Okay, so for part E, we say that answer in B is more accurate. What can we conclude? We only round off at the last step. Do not round off in the middle. This boxed up text, it says if a problem requires answer that is correct to 3SF, SF for significant figures, sometimes the question will say find the answer correct to 3SF. Then in the middle, the exact value of, wow, too long already, too many decimals. We don't expect you to write everything down. We expect you to at least put 5SF first. At least 5SF for intermediate step. Okay? So let's try practice number 5. Actually, this should have been done already. The area of a square is 131 square centimeters. Find the length. So in part 1, length. Length of a square is going to be the square root. Square root of 131. So when you do that in your calculator, we get 11.4455 and so on and so forth. Now, I require in our mathematics, okay, by default, when the question doesn't say, by default, leave non-exact answers to 3SF. So whenever you have answers that are irrational, you put it down as 3SF. So in this case, 11.4455 blah 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 blah. We cannot write everything down, too long already. So how do we round off? You don't round off to 1 decimal place, 2 decimal place, 3 decimal, that's primary school stuff. We round off to 3SF. So here, 11.4 cm. This is the length. Okay, so that's for part 1. So sometimes we put a 3SF in bracket over here to remind ourselves, okay, this is not the exact, I just put it in 3SF. Because in secondary school, if the question don't say, I put it on in 3SF. That is the safe thing to do for answers that are not exact. Now in part 2, find the perimeter of the square. So perimeter, what is the formula for perimeter of a square? Perimeter? If let's say for a square, this side 10 cm. What is the perimeter? 40, isn't it? How do you get 40? How do you get 40? 10 times 4 all of them are 10, right? 10 times 4. Okay, what if it is 90? What is the perimeter? 360. How do you get 360? So again, 4 times 90, isn't it? So you get 360. Now, in this particular case, our length, we found it in part 1. What will your calculation for the perimeter be? I believe you have to start with 4 times something, right? 4 times something, right? What will you put in the bracket? 11.4? Shall we put 11.4? Is 11.4 accurate? Or is it a rounded off value? Rounded off, right? So if I put 11.4, I know answer not accurate already. What is a better number to put? 11.4455. The more you put, the better, right? The more you put, the more accurate. Is there something that is even better? Wayne suggested it, and he is correct. Is there something else you can put inside here? Very exact one. 5 significant figures will be your 11.446. But Wayne has something more accurate. How about you put square root 131? Isn't that even better? Oh, no rounding off, right? Then you let your calculator do the work. 4 times square root 131. Let your calculator handle it. You get 45.782. This is in 5 SF, but the question wanted it in 3 SF, so you round off to become 45.8 cm. Can? So now, still with your calculators on the table, what would your answer be if you used the length 11.4 to calculate the perimeter? Try it now. If you use 11.4 as the length, what will your perimeter be? How much do you get? 45.6, right? Is it the same as my 45.8? Different. Which one more accurate? The 45.8 is more accurate. Alright, and how did it become more accurate? Because I used the exact value of 1 square root 131. The moment you use the 11.4, you have to know that not accurate already. Okay? Now practice number 6. The wall measures 2.12 by 5.78. Give an estimate of the area. So part A, always state what you are doing. In this case, area equals to 2.12 times 5.78. Since they wanted us to estimate, I will just round it off to something convenient for me. 2 times 6, yeah. And I get 12 square meters. This is my estimated value. Calculate the area of the wall correct to 3SF. Okay, correct to 3SF. So area, this time we need to put the exact 2.12 times 5.78, 12.2536. Round it off to 3SF, 12.3 square meters. So this is in 3SF. And just to take note, you don't need to write this red one, this is accurate. This is the best value you can use, 12.2536. But too many numbers lah. You know, when you want to tell somebody the area, you don't have to say everything out. It is estimated to be 12.3. Part C, the cost per square meter of painting the wall is $3. Okay, every square meter costs $3 to paint. How much does it cost to paint the wall to the nearest dollar? So 1 square meter costs $3. 1 square meter costs $3. How many square meters do we have to paint? How many square meters do we have to paint? I see 3 numbers up there. Which is the area I should use? Should I use 12? Should I use 12? You sure? Should I use 12? Should I use this 12 to calculate the cost of painting the wall? Maybe, have to decide lah. Huh? Yes, you're gonna use this one to. Okay, so there are 2 other values, Okay, I've circled down the 3 values. Which one are you going to use to calculate the cost of painting the wall? The second one? The third one, 12.3. You know, whatever you choose, you have to have a reason, What will you choose? Shinky, what will you choose? The first, second, or third circled number? Second. Anybody chooses anything else? So what is the reason for choosing the second one? Do you have a very strong reason for choosing the second one? Yes? It's not rounded off. It's the most accurate, right? There's no error over there. We should use the second one. So 12.2536 square meter costs. So how much will this cost now? 3 divided by 1 times 12.2536. The $3 12.2536. We get 36.7608. This is the exact value. However, they wanted us to round it off to the nearest dollar. So to the nearest dollar, it becomes $37. So if in Shira, if you're the painter, and then you choose to bill your customer, hey, you know what? I'm just gonna charge you for 12 square meters. That's your first choice, right? So you choose 12, you thought it was okay. So if you choose 12, you're gonna end up earning 12 times 3. You're gonna end up earning $36 only, no? How much should you be earning? You should be earning 36.7608. So if you do not know which value to choose, you may end up shortchanging yourself. Okay, next one. Suppose you're the designer of a lift that can carry maximum mass 897. However, you are told to put a maximum mass correct to the nearest 100 kg. What will you choose to put as the maximum mass and why? Okay, so you were given time to think. Now, what did you all choose? 800? Okay, one suggestion, Wayne says he will put 800. Very strangely. Any other options? Any other options? 900? Any other options? I think it probably boils down to these two. What would you choose, 800 or 900 as the weight limit? If you're the designer, and then your engineer tell you, hey boss, this lift maximum only can carry 897 kg. Anything more than that, right, the cable snap, very dangerous. People may get injured. Okay? Engineer tell you, you're the boss, you're going to be indicating on the panel maximum load equals to how many kg. Now, you do not want to put 897 over here. That's a very funny number, right? 897. But your engineer tell you cannot be more than 897. You want to put a number that ends with 00. Very nice number to see, hundreds, right? What will you put? 800 or 900? Is it clear now? We put 800 or 900? 800, right? We will choose 800. Although 900 is closer to 897. But 900 is too dangerous. What if really the people go in really 900 kg? Dangerous. Dangerous. So we have to use our logic also. Depending on the situation, whether you round up or you round down. So we put 800 kg as maximum mass. So why do we put 800 kg as the maximum mass? Now if we put 900 kg, it would exceed the maximum of 897 kg and be dangerous. So these are the textbook homework questions for the end of your chapter 3 part 2 notes. From textbook exercise 3.3, question 1C. Without using calculator, estimate expression by rounding off again each number to 1SF. So for the first one, part 1C, we round this off to become 40000 times 0.003. All these are in 1SF already. Okay, so you carry on to put on the equal sign. We end up with 120. The next number, again they said round off each number to 1 SF. So if you still need help over here to identify where The decider is, just remember the first SF is the first non-zero number. This is my first SF. So since I want it to be run out of the first SF, I draw a line after the first SF. The next number, this is my first non-zero, so that is my first SF. So draw a line over here. So if you needed help for the previous case, this is my first SF. Draw a line over here, and then the first non-zero is the 2. This is the first SF. It is the first non-zero, so draw a line over here. Yeah, I hope this helps you if you need it. So carry on. Answer. When you round it off, it becomes 6 square. Don't forget the square. Divided by 4. So we get 36 divided by 4, which is simply 9. So first question done. Second one. Okay, now we have some estimation to do. The length of the sofa is 2 meters. So it looks like using the tiles are 2 squares. Approximately, this portion is approximately 2 meters. So the length of one square should be 1 meter. Approximately. Okay, so they want the length of the cabinet. So I've got 1 tile, 2 tiles, and a bit over here and a bit over here. It looks like it is approximately 3 tiles, right? So in part A, length equals to 3 times. Okay, not equal, approximately, 3 times the length of 1 tile. And what is the length of 1 tile? It is 2 divided by 2 lah. That table, that sofa over there, 2 meters, right? So we check, 1 tile is about 1 meter. So our answer will be 3 meters. And then in part B, the width of the table, width. So this is the width of the table. It is about 2 over 2, which is about 1 meter. Don't you wish you had this kind of questions for a test? Maybe, maybe. The next one, rectangular field. Similar type to our notes question. 64.19 meter, 25.68 meter. Find area correct to 2 SF. So in part A, we need the exact. Part A, area 64.19 multiplied by 25.68. 1648.3992. This is the exact, okay? Then we round it off to 2SF. Draw a line over here. The decider is 4. So we end up with 1600 square meters. So you can put on that this is in 2SF. Okay, you can use a pencil to indicate, just to remind yourself, this is the exact value. That is the best. That's the exact. Just that too many numbers lah. We usually don't use many numbers, huh? Next, B part 1. Express the length correct to 2SF. So length is approximately, it is 64.19 to 2SF. We get 64. And in part 2, breadth is exactly 25.68. You round it off, you get 26 meters. So this is where you put the line. Then using the approximate value, see part B, B part 1, part 2, we have approximate values. Approximately 64, approximately 26. Then they want us to use these two values to estimate area of the field. Area, part 3, area is approximately 64 times 26. 1664 square meters. Okay, so now they ask you, okay, we've got two values. In part A, we have the answer 1600, and then we have 1664 in part B, part 3. Are they the same? If not, which answer is more accurate? You know what, I would like to make an amendment to part C question. Okay, instead of answers in part A and part B, part 1, is the exact answer in part A. So I don't want to compare the 1600. I would like you to compare this. Compare the two highlighted parts. Okay, 1648.3992 versus 1664. Which one more exact? Which one more accurate? Now obviously they're different. Then the first one was accurate, right? I already put it as exact. So I want you to understand how did we end up with two different answers. That is the most important part for this type of question. How did we end up with two different answers? Well, in part B, we went to round off the exact 64.19 to become 64. The exact value of 25.68, we rounded it off to 26. Of course, when you multiply two non-exact answers, you get something that is inaccurate. Okay, so put down the answer over here. Part C, not the same. A is more accurate. A few more questions to go. Estimate the total mass by rounding off each mass to 2SF, every single one to 2SF. So part A. Total mass is approximately, so 2SF, let's draw the line down for every single one of them. So approximately 72, 73, 75, 75 again, 76, 74, 78, and 77. So this gives us $600. Oh, really? Is this the answer you all got? 600? Oh, okay. So this is approximately 600 kilograms. So based on the estimation, just by using this value and using information in the question, 600 grams is the maximum. Is it safe to let these 8 people enter? Is it safe? Based on this information. Yeah, safe one. So B. Yes, it is safe. Because maximum is 600 and my estimate is 600. However, if we were to calculate the actual mass, part C, actual mass, let's add everything up. I will not write down everything, just use your calculator. 71.8, 73.4, 75.3, 74.8, 76.4, 73.9, 78.4, and 77.4. You end up with, oh no, 601.4 kilograms. Now, is it safe to let these 8 people go in? No longer safe, right? It is more than 600 already. So, it is not safe to let these 8 people enter. So in part D, it says, hey, can you think of a way to estimate such that when you estimate the mass, it will not be overloaded. The total estimated mass will not be greater than 600 kg. How should we estimate such that it will always be safe? I mean, we have seen that, hey, by rounding off each mass to 2SF, we may end up with a problem. So maybe rounding off to 2SF is not a good idea. What other ways could there be? So one of which, yes? Round? Round up. No matter what, you round up. You never ever round down. Will that work? Huh? No matter what, if it is, for example, 70.1, we round this up to become 71 to the nearest kg. We don't round it down to 70. This is dangerous. We always round up so that no matter what, your estimation of the mass is always an overestimation. And as long as your total overestimation is less than 600, I guarantee you will be safe. Make sense? Yeah, so I think this works. So in part D, the strategy you could have is always round up the masses to nearest. You can say whole number, you can say integer, up to you. Okay, because all these masses they can only be greater than 0. You can have a person mass 0, right? Then the person doesn't exist. So we're only talking about positive whole numbers. You can say whole numbers, or you can say integers. Be more professional, you put integers. Okay, just a couple more questions from the review exercise. Now evaluate this, giving answer in the exact value. Okay, simple. 3.5 times 7 1/3. Then last bracket negative 1 and 1/8. Close bracket divided by 2 and 1/4. You get what exact value? So I have 25 and 1/6. Is this what you had? Or do you leave it as a decimal? Can we leave it as decimal? Can. What's the decimal? Can or not? Huh? 25.16 recurring. Okay, I can accept that. Or 25.16 with a dot on top. This one can. But if you choose to write 25.166666666, you'll see your calculator got how many 6, you write how many 6, then it's wrong, okay? We wanted exact. So either one of these two will be exact. Of course, you can leave it as a mixed fraction also. Or, as an improper fraction, 151/6. So these are the 3 acceptable answers that I can have. And then in part B, correct to 2 decimal places. So 25.17. Because it's supposed to go right, 666. Okay, let me just put it down for you. So it goes on 66666. We round this off to become 25.17. This is 2 decimal places. And then in part C, 25.1666. Round this off to 3SF, right? You notice that we don't need to write so many 6s. We don't need so many of them. That's why you say generally 5SF is enough. I mean enough with 25.2. Now, question 4. I crossed it out. Do you all take physics, right? Physics? No? No physics. No. I have, right? Go ahead, man. Chemistry? Oh, okay. So that's how you divide it now. Okay. Then all the more, I do not want you to do part 4, question 4. Okay, we skip this question. My issue is with this word accuracy. May I just thought, I just give you a bit of an information. Okay, so if I've got a, people go archery, right? Then there's the bullseye in the middle. So these are 4 cases, okay? 4 cases, This is the performance of the first guy. This is where he shoots. What do you think of his performance, the first guy? Good or bad? Bad, right? Okay. Second guy shoots like this. What do you think of his performance? Better or still very bad? But would you say he's better than the first guy? No, Okay. Let's look at the next one. What do you think of this guy? Good? Okay, and final guy. What do you think? Can you see the 4 different cases? Can you see that they're all quite different? So, which one will you describe as accurate? Okay, I label them for you. This A, B, C, and D. Which one is accurate? C and D? C? Okay, this is accurate. How about D? Is it accurate also? Accurate? You want to shoot in the center, right? Both C and D are quite accurate. However, between C and D, which one is a better performance? D, right? Can you describe to me in what way is C not as good as D, or in what way is D better than C? Very what? Precise. See the word precise? Whereas in C, although accurate, all generally in the center, but they are very far apart. They are slightly further apart, right? So we say that this is accurate and precise. Whereas in C, it is not precise. Okay? Now, using these 2 keywords, accurate and precise, can you describe the scenario B to me? Using the 2 words, accurate and precise. Is B accurate? Is the person accurate? Not accurate, right? Hey, everything very far off, so it's not accurate. Not accurate. But is he precise? Everything all very close to each other, right? Maybe something wrong with his gun on that day. Something wrong with it always cause him to shoot off in one corner. Okay, so he said that this is very precise. Okay? How about A? Not accurate, not precise, right? These are lousiest, don't know what he's doing. So this is not accurate, not precise. Okay, now, what has that got to do with this weighing scale? You have 2 weighing scales in this scenario. Scale A displays the mass as 53.0 kg. The second scale displays it as 53.00 kg. Do the 2 scales measure his mass to the same degree of? This word is wrong. It should be precision. Because whether it's accurate or not depends on the quality of that machine. But when we talk about precision, we are talking about how fine the details can be, how close to the actual value you can get. So there are things that you can use to measure things like distance. You can use a meter ruler, you can use a 30 cm ruler, you can use a 15 cm ruler, you can use very specialized instruments to measure the width of a human hand. Your ruler cannot do that, right? Your ruler has a precision, 1 mm. Your human hair is smaller, thinner. more fine than 1 mm. You need something more precise, something that can go very, very precise with many decimal places. So in this case, this question is supposed to be talking about precision, not accuracy. Okay, so that's why I didn't want you to do this, but I'll just explain it to you. Do they measure to the same precision? No, they do not. Explain which weighing scale measures his mass more precisely. So the answer is the scale B. Scale B measures it more precisely. Reason? It offers more decimal places. It offers more significant figures compared to scale A. So we're going to get very precise reading, 53.01 kg, whereas the scale A can maybe read up to 53.0 only. Okay, next one. We've got Hao Chen and his family from Beijing want to visit, stay in Singapore for 4 days, 3 nights. Needs to buy 3 air tickets, book 1 room, 3 nights. Estimate total amount that he has to pay for ticket and accommodation. So part A, total is supposed to be Hao Chen and his parents, right? So 3 people. 3 times of $562 plus 198, 189, and 209. This is the actual exact calculation, but they only wanted you to estimate. Okay, let's estimate. You know what? I don't want to multiply by 562. Let me just estimate it to be 600. I don't want to work with 198. Oh, they are all about 200. So this is my estimation. And I get 1008, 2000, 2004. So this to me is to the nearest 100 already. And then in part B, it says that the conversion, 1 Sing dollar to 4.89 RMB. Estimate the total expenditure in RMB. Okay, so the estimate total expenditure, estimated total is equal to, we are just going to estimate 2,400. We're going to use that 2,400. I don't need the exact value because they tell me estimate. And I'm going to multiply by, you know, I don't want to multiply by 4.89. Let's multiply by 5. Since it is just an estimate. So we end up with $12,000. Sorry, not dollars. So weird. Okay, 12,000 RMB. Okay, so this is to the nearest 1,000 RMB already. Okay, so that's all for our homework for chapter 3.